Hello, welcome back to Cinderella Math. Today I will be going over determining if a relation, which is just a set of points really, whether or not, so a yes or no, is it a function? All right, I would say this is a pre-algebra topic, but if you're in Algebra 1 or even Algebra 2, this is good knowledge as well. All right, so again, a relation is just a set of ordered pairs, but a function, let me actually write this definition down for you. I'll just write it right here on this title page. Maybe if my pen wants to come to life here. Here we go. A function is a set of ordered pairs where all x values are unique. Now, if you look it up on Google or in your textbook, it may have a slightly different definition. Kind of depends on what level of math you're in and all that good stuff. But that is essentially what we're looking for. We want for something to be a function, all x values to be unique, and of course unique means different. So my joke is that x cannot get married twice. Let me show you what I mean by that. Okay. So is it a function, yes or no? Let's look right here at your top corner. I'm going to call this right here example 1. I have just listed out a set of ordered pairs. Okay, so this is a relation all day long, what I'm underlining in red. We could graph that. It's a set of pairs. It's fine. It's points, right? So it's a relation. Is it a function? Which again means all the x values are unique or different. And remember, in an ordered pair, x, y. So you only need to look at the x values. Grab a highlighter or a colored ink pen or a colored pencil or something. Just look at the x's. So here in example 1, let's circle all the x's. I'm doing that in my blue pen. Are they all different? We don't even care about the y's. Don't even look at those. Different, 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 different. Be careful, that's -6, that's 6. They're different. This is a function, and all you need to write is yes. If your teacher's really uptight, you might write yes, comma, this is a function. But for me, yes. Okay, that is it. That is all you have to do. Let's look over here, example 2. I've given us another set of ordered pairs. Remember in upper level math that squiggly braces right here, these squigglies, that means it's a set. So again, these are good points. Here in example 2, we could graph it if we really wanted to. They're fine, but is it a function? Just look at your x values, again circling in blue. We have 5, we have 6, we have 5. Oh no. He repeated 5 and 5. These are not all unique. So you just need to say no. Again, if your teacher's uptight, no, comma, this is not a function. And again, with my joke, 5 got married to 9, and then he got remarried to 11. That is not allowed. Okay, your x cannot get married twice. I know that's kind of a silly joke, but it does work. If the joke doesn't help you, feel free to ignore it. Now you could be given a chart. Some teachers call these charts. Some people call these tables, x, y chart. If you're in higher math, it might say, instead of y, it might say f of x. That's fine. Same thing, right? It's all good. Where x is our input and y, or f of x, is our output, right? These, I think, are even easier. So again, let's come to example 3, to your left, bottom left there. You just need to look at the x's. So are these all different? 1, 3, 6, they're all different. This is a function. As long as your x's are all different. Don't even put your eyeballs on the y's. Yes, these are the same. Doesn't matter. Don't care. This is a function because all the x's are different. Come over to example 4, bottom right. Look just at your X's. Uh-oh, 1 repeats. He got married to 2, and then he got remarried to 9. That's not allowed. No, this one is not a function. It's a relation, which is a set of ordered pairs, but it is not a function. Okay, now I'm going to pull up some graph paper, and because another thing we could do, we could give you the set with the squiggly brackets. We could give you a table or chart. We could also give you a graph. Okay, alrighty. And I'm just going to randomly graph some points here. So give me 1 second. Okay, good enough. All right, so if they give you just a graph of points like this, and they're not connected, there's no lines, there's no squiggles, they're just points. This is known as a discrete graph. You probably don't need to know that, especially if you're in pre-algebra, algebra 1, but there you go. There's 2 things you can do with a discrete graph. The first thing you can do is just write down the points. Now this will take a second, and if there's a whole lot of the points, this is not the best method, but I'll show you anyway. And then I'll show you a better method. But just in case you want to write down the points, I always start at the left like you're reading a book. So I'm going to go to the point that's farthest left. I'm going to just put a little check there. So that is, see they're counting by 2, so that looks like it's -7. Up, 1, 2, 3, 4, 5, 6. And then just keep going, moving from left to right like you're reading a book, writing your points. So this one would be next. So that's 1, 2, 3, so -3, 1, 2, 3. And then this one would be next as we make our way from left to right, just like we're reading, you know, the cat ran, you know. So this is over 1, up, 8, and our final point to your right-hand side, 4, 6. Technically, that's a list. Put commas in between and squiggle because that's a set of points that we have graphed. And now you do exactly what we did on the previous slide. Just look at the x value. Remember that a point is xy, so just looking at your first number. If they're all different, this is a function. All those are different, this indeed is a function. Now, that was only 4 points, but it was still annoying. And what if it would have been like 10 points? Super annoying, right? I mean, hard, no. Annoying, yes. So, there is another way to tell on a graph, and it is something called the vertical line test. If your graph passes this test, it is a function. And if your graph fails this test, it is not a function. Okay? So, what is this test? If you take your pencil or your eyeball or whatever and you draw vertical lines, so you can just mentally do this, or if you actually have a printout of a graph, you can physically do this. You're going to draw vertical lines. And if it hits just once, it's fine. So that red line hit no times, this hit none, none. This hits once, 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 once. As long as any vertical line would hit either no points or 1 point, we're good. So I would say this graph right here passes the vertical line test. So it is a function. Okay, again, it's just vertical. And if you don't have it printed, or if you just, even if you do, you don't actually have to draw these. You can probably, especially after a couple examples, you can just look with your eyeballs. That's going to pass, right? Because it's going to hit once, 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 once. Okay? Let me change the graph. Give me 1 second. Okay, we could again write down the points. I'm not going to, but we could. That would take a minute. Let's do the vertical line test. Okay, that hits once, that hits twice. As soon as you hit twice or more, if there was more points, it doesn't matter. As soon as you hit more than once, it is a no. What I have graphed there, those red dots, do not represent a function. And as soon as you hit one, just as soon as you hit more than once, you can just say, no, I don't even need to check the rest of it. It's done. This is not a function. Okay? Now that's if it was just points. So that's again called a discrete graph. What if it's connected? Okay? So that thing there, that's if you're in Algebra 1, you might know the name of this shape. That's called a parabola. It's not important really, the name though, for this lesson. It has infinite number of points on here. There's points everywhere, and they're not all whole number either. So it would be pretty much impossible to write down all the points. Okay, so we're not going to do that. We are just going to do the vertical line test on this guy. Okay, so either mentally or, again, if this was printed, you could take your pencil or pen and you could say, okay, hits once, 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 once. This is a function. Because no matter where I draw a vertical line, it will only hit that graph either no times, like over here, or once. So it is a function. Okay? What if I turned it the other way, though? Okay, so that is still not, that's not a discrete graph. So we're not going to write down the points. We're going to do the vertical line test twice. Once, twice. You don't even have to go anymore. As soon as it hits more than once, so twice, say no. This is not a function. It's still a good graph. It's still, you know, a mathematical thing that we can work with, especially in upper level math. But for today's lesson, that is not a function. And if you actually did like write down these points that, you know, this x value is the same as this one. Like, well, my line's not perfectly straight, but hold on. Let me actually just redraw the graph just a smidge better. There we go. All right, something like that. Right here and right here, these would be the same x values because that's over 0 up 6 and over 0 down 4. So see, 0 got married twice. And so with this one, -2 got married here and here. 4 got married here and here. So this fails just so many times, but you don't need to write down the points. As soon as it hits twice with a vertical line, no, this is not a function. Okay? All right, I think that concludes this video. If you have any questions, please feel free to put them in the comments below. I hope you're having a great day, and I hope to see you back again soon. Bye-bye.